Problem number 268, missing number. Given an array nums containing n distinct numbers in the range of 0 to n, return only number in the range that is missing from the array. So this is a missing number problem wherein we have to find whatever number is missing. For example, they have given us an input of 301 wherein we see that there are nums of length is 3 and the range they have given is from 0 to n, that is 0 to the number nums dot length. So the missing number they have is number 2. And if you see the next example, they have given an example of 0 and 1, and the missing number here is number 2. Why it is that? Let's try to understand this. If you go down, you will see the constraint, which is very important because they are saying all the numbers of nums array are unique in nature. This is a very important, and you can ask this as a question to the interviewer. All the numbers are unique in nature. N is nothing but nums dot length. So whatever they are mentioning over here in the question containing n distinct numbers from 0 to n, that is from 0 till nums dot length, whatever the number nums dot length is, that is the range they are providing us. Next, if you see here, this is a very important point that nums of I is inclusive of 0 and nums dot length. So that means the nums dot length will always contain 0 till whatever the length is. For example, here the length is 3. So it will contain all the numbers till 0 till 2. Here the length is 0 and 1, that is the length is 2, right? So it will contain all the numbers from 0 to 2. That is what is the question is saying. Let's start and try to analyze this question and come to a proper solution for this. So over here, the first question, so the first, if the nums array, if you're taking this nums array 3, 0, 1, the simple method or the simple solution is we have to first sort the array, whatever the array is given, we have to sort it. After sorting, we will get the array in sorting or increasing format 0, 1, and 3, right? Now, once we get this sorted array, simple what we can do is we can compare this with the indices, because indices will also be inclusive of numbers, right? So it is inclusive of, it will be till 3. It is inclusive of the length. What is the length? It is 3. So it is inclusive. Equal or inclusive. That means less or equal to the number 3. So these are the indices, right? These are the indices of these numbers. If you carefully watch, you should able to compare the indices, the index versus the value, and you over there you see there is a difference between 3 and 2, which is why we say that 2 is the number which is missing. Let's take another example to make you more understand better. So 3014. Okay, this is the nums array. Okay, first thing first, we have to sort it. The sorting method will help us in this way: 0, 1, 3, and 4, right? Now, n is equal to nums dot length. That is what they have given. What is nums dot length? Nums dot length is 1, 2, 3, 4. Nums dot n is equal to 4, right? N is equal to 4. Simple. What we have to do is we have to start numbering the indices. Index is 0, index is 1, index is 2, and index is 3. Now compare these indexes along with the nums value. So here you get 0, 0, here you get 1, 1, we are good. Here you get 3, 2, and we get the difference, right? We get the difference. That's the reason we say the number missing over here is 2. The number missing over here is 2, since this is the difference which we have seen it first. First difference we have seen is this, and that's why we are going to return the answer as 2. We are going to return the answer as 2. Next example, let's see the next example. In case of if you have some numbers like 301, 2 and 4, what is going to happen in this condition? We are going to sort it. So let's sort it 0, 1, 2, 3 and 4. Now, in this case, they are asking us the missing number. They are asking us the missing number, right? So again, we are going to give the indices 0, 1, 2, 3, 4. And we are going to start comparing the indices along with its value. So 0 is compared with 0, 1 is compared, 2 is compared, 3 is compared, 4 is compared. Everything is same. But if you observe our indices, that is the indices are till is inclusive of the length, inclusive means it includes the length, right? So how many are this how many are how much is the array length? Let's see that. 1, 2, 3, 4, 5. 5 is the length, right? And indices are just till 4. So actually we have an indices till 5, right? So that's the reason we say that if everything is matching, then what is missing is nums dot length. That means the value 5 is missing. So if we have the same value as that of indices, then we are going to return the last value, that is the nums dot length, that is the 5. That is the 5, and that is what they have done in example 2. See, if you see 0 and 1 are there, and they are telling that answer is 2, output is 2. Why? Because they are comparing the indices. So 0 and 1, everything is clear. So if you see here the example, same example, 0 comma 1. Okay, here anyways the sorting was not needed. They put an indices 0 and they put an indices 1, which is completed, but actual indices is still nums dot length. What is nums dot length here? Nums dot length is 1 and 2. So actual the indices are 0, 1 and 2, and here 2 is missing, and that's the reason they're returning 2. So if everything, simple as that, if everything is similar, then we have to return nums dot length. That is what the question is letting us know. If everything is similar, 0 is similar to 0, 1 is similar to 1, 2 is similar to 2, and if 3 is not there and the length is 3, then we have to give nums dot length as 3, or we have to give answer as nums dot length. Hopefully you guys have understood what I'm trying to say over here. Like let me give one more example. 0, 1, 2. Let's do this way. I have given this example, but let me again tell you. 0, 1, 4, 2, 3. Okay, here I'm going to sort it simple. 0, 1, 2, 3, 4. Right, I have sorted. This is sorted array, and whatever the indices, that is I, are is indices, which is inclusive of nums dot length. 0, 1, 2, 3, 4. If the value of nums of I and I is same, if both are same, I value and nums of I value is same, then I'm going to return nums dot length. And what is my nums dot length? Simple. What is the nums dot length over here? 1, 2, 3, 4, 5. So I'm going to return the answer as 5. 5 is missing. Okay, so the time complexity wise of this approach, we are using sorting. Usually we have to use sorting because they haven't given us that this is in sorted format. So the time complexity is O of log n. That is a time complexity because we are using sorting method, but we can use another approach for this missing number, which is much more better than this using the sorting method. So let me show you that method. Here we have 301, right? So we can use a data structure which is a hash set. So in the hash set, what I'm going to do, I'm going to copy all the nums into hash set. So this is a nums array. I'm going to copy this into my hash set, that is 3, 0, and 1. Okay, I'm not going to use sorting over here. This is the hash set which I'm copying it. Now I'm going to traverse the for loop from 0 to n. What do you mean by 0 to n? What is n over here? The constraint, see the constraint. The constraint is n is nums dot length. So I'm going to start my for loop from the range of 0 to 3, right? From the range of 0 to 3, I will start my for loop, and then I will be checking if my set contains that number, then I'm good. If set does not contain that number, then return that number. Simple. So let me show you again. So if my nums array has 3, 0, 1, this is my nums array. I'll create one hash set which has same 3, 0, and 1. These are the hash set nums. Now what I'm going to do is I will be start my for loop from I equal to 0, I less than n, I plus plus. What is n over here? N is nums dot length. This is given in the constraint. And then I'll say if my set does not contains I, if my set is not containing this value, then return that value, return that I. That means if my set is not containing 0 till whatever the length is there, if it is not containing in the set, of course the set does not contain number 2. Come on, this we can see. Set is not containing 2. So return 2 as my answer, right? That is what I'm trying to say. This is what we are going to do as our solution. Or else if set contains that particular number, then we are okay, right? We don't have to return anything. If it contains number, we are good. And this is how we can solve this problem. And time complexity wise, it is O of n time complexity, because we are using the data structure has set over here. And space wise also, it is O of n time complexity. And I find this solution as a better solution, since there is no log of n. And another thing is we are taking complete nums dot length less than equal to n. We are taking all the nums dot length from 0 to n. We are traversing and checking. So that will help us to find out the entire, even this kind of a solution can be, we can find out, because we are taking inclusive of nums dot length. In earlier solution, when we are traversing the for loop, we were not taking that inclusive. That's the reason this solution finds to be a good and a better approach. Let's start coding. Public static int missing number. So they have given us the nums array, and as I told you, I'm going to create a hash set. New hash set. I'm first going to traverse the nums array, because I have to add in the set dot add num. Once this is done, then I'm going to traverse for int of I equal to 0, I less than equal to nums dot length I plus plus. If set dot contains, if set does not contains I, then return I. This will help us to find each possible operation, because this is the inclusive of nums dot length, right? So whatever the nums dot length, suppose the nums dot length is 5 and fifth number is missing, then still it will find out with this help of the solution. That's the reason I use this solution. So time complexity wise, it is O of n time complexity, and space is also O of n space complexity, because we are using the hash set. Thank you for watching.